Hello everyone, today let's take a look at a super simple combinatorics question, QP number 30, in how many ways can 10 people be seated in a row such that a certain two enemies are not sat next to each other? So we have 10 total people, and let's say person A and person B do not like each other, they're enemies, so they can't sit next to each other. So in order to solve this, we're just going to count the total number of ways to seat 10 people in a row, and we're going to subtract off the number of ways to seat 10 people in a row where A and B are also adjacent to each other. And obviously this will just leave us with the number of ways to seat 10 people in a row such that A and B are not adjacent to each other. So let's calculate this first, the total number of ways to seat 10 people. Well, we have 10 places to put our first person, 9 to put our second, and etc. So it's going to be 10 factorial different ways to place 10 peoples in a row. It's just the number of permutations. And how are we going to solve this part of the equation? Well, let's just fuse A and B into one entity almost, and then permute it with all the other people. So now what we're doing is we're taking our 9 entities, right, 8 normal people plus 1 instance of A and B together, and just permuting these and seeing how many we can get. Well, we have 9 things to permute, so we have 9 factorial ways of permuting them. But now don't forget, if we expand this A and B together block such that we have A and B, well, there's going to be 2 factorial ways of permuting these equals 2, right? We could have A and then B, or we could have B and then A, and these are both solutions where A and B are next to each other. So we have 9 factorial ways of permuting the version where B comes before A, and we have 9 factorial ways of permuting the version where A comes before B. So let's multiply 9 factorial by 2 to get the total number of invalid permutations. So now we have both the left side and the right side, so all you have to do is our final answer is going to be 10 factorial minus 2 times 9 factorial. And this is just going to be, after plugging it into a calculator, some really large number, 2,053,040. So this is our final answer right here.